Okay, so we're going to start on 3.05. I know we went over it before, but we're going to do a short review and then move on to 3.06. So 3.05 is the discriminant of the quadratic formula. If you'll remember, the quadratic formula looks like this: negative b plus or minus the square root of b squared minus 4ac all over 2a. This is the discriminant part of it. So you take this, you identify those pieces. So if you have a quadratic will look like this, or something along those lines, and you're looking for the coefficients. This is a, this is b, and this is c. So our a is that understood 1 by x squared, our b is that 3, and our c is that 7. And now we plug these guys in here. So 3 squared minus 4 times 1 times 7. So that's 9 minus 28. I made this one up. So 9 minus 28 is negative 19. And remember, we can tell several things about the discriminant. There's a reason to calculate it. It's not just for fun math, you know, if you're just bored at home and trying to do some math. You can find out the number of solutions that you're going to have. Remember, if we have a negative number for the discriminant, then we are going to have 2 imaginary solutions. If it's 0, you are going to have 1 real solution. And if it is positive, then you are going to have 2 probably real, I don't know exactly what word your homework is looking for, but it's probably going to be real or irrational. It's a 0.
Oh, okay.
So this is 0. So you can also identify the number of x-intercepts. I know that's in your lesson. There's like a chart for it because I saw it the other day. And everything else you can answer just like this. This is the type of solution. This is the number of solution. And this is what you can use to judge it by. So if we do number 2, number 2 is negative x squared minus 6x minus 9 equals 0. So we're going to identify our a, b, and our c. Our a is negative 1 because we have this negative and then the understood 1 there. We have a negative 6 here. The sign always goes with it, and a negative 9. So all 3 are negative. So now we have our discriminant, which is b squared minus 4ac. So when we plug in, we need to remember to plug in our signs as well. So I use parentheses around them. So now we do negative 6 squared, because that's going to give you a different answer if you just plug in negative 6 squared or parenthesis negative 6 parentheses squared. You're squaring that whole negative 6. You're going to get a positive number here. Minus 4 times negative 1 times negative 9. So we're going to get 36 minus 36, it looks like, or 36. We end up with a negative because we multiply a negative by a negative. This makes a positive. Then we multiply by this again, so we get a positive. And we're going to get 36. So we're going to end up with a 0. So about our equation up here, the things that it wants are the value of the discriminant, which we have right here. We want the number of solutions, which we can consult our chart for. So we know that we have one real solution, and the type of solution will be real. And then let me pull up the lesson, and I'll be able to tell you how many x-intercepts it has. So if it is bigger than 0, so if it is positive, you are going to have 2 x-intercepts. So I'm just going to put another 2 here. Actually, I'm going to put it down here at the end in another color. 2. If it equals 0, you have 1 x-intercept. And if it is less than 0, you have no x-intercepts. So this can also be written as no real solutions, because imaginary and real are opposite. So if you have 2 imaginary solutions, you don't have any real solutions. So let's move on to 3.06. You okay, Jacayla? Okay, graphing functions in standard form. We have talked about this. Wait, never mind. This is standard form for this is standard form for quadratics. So this is what it looks like. Well, I thought I was going to put it over there. Do what? Yes, I pulled up 306, and I don't know where it went. There it is. Okay. So this is what the homework assignment looks like. The task requires you to create a graph. You can use all the regular options. Find the axis of symmetry for y equals this. So I vote we plug this in a symbol lab and look at it and talk about it. So I'm going to bring a web browser down there, and we will plug it in. Okay. So let's plug this guy in and see what happens. I mean, that's what, I don't know if it'll work, but if it doesn't, we'll change. Okay, awesome. So y equals 4x squared plus 16x minus 2. Okay, so we plug that in, and it tells us all this useful information about it. And we scroll down and we find a graph. So we're looking for the axis of symmetry. So we're really looking for the line where we can lay a mirror down on this, and it will look the same on both sides of the mirror. So that line is right here. It goes up and down. So it's going to go through this global minimum, which is because just that's kind of in the middle of it. So we find the global minimum and we say, all right, well, we need to identify that line. So -2 is not a line. -2 is just a number. So if you're on the right track. So if we take and we use this as what we need. We know that we need to go over -2, which Jacayla was right about. And I'm going to go over here and draw that real quick, so that way I can work with it a little more. Okay, that is kind of what it looks like. And this is -2, -18. So if it's going left and right, this is what we're going to need. And we are going to need this little mnemonic way to remember it. If your line is horizontal, it's 0 equals, or that's your slope, and it's y equals whatever it is. So our line is vertical. So our line is vertical, and it's going to be x equals. So this line will be x equals -2. So this came from up here because I know we have a vertical line right here because that's how our mirror has to face. This x right here came down here, and then this -2 came up here. So that's how I got that from what I had. This is how you remember it. If it's horizontal, you really don't need to worry about the second part of this yet, just these. So if it's horizontal, it goes with y. If it's vertical, it goes with x. So that is the axis of symmetry for that. So let's roll back over here and see. It looks like it's giving you choices here. So B would be your choice here.
Wait, I have a question. So the line is horizontal, like
if the mirror is horizontal, like when you lay the mirror down and it reflects across it, that is what you're talking about. Yes. That is a vertical line.
okay.
Like this is vertical, so that across it. So this is x equals. This is horizontal. Yes. You got it. Think about the horizon when you're trying to remember which way horizontal is.
So horizontal is y, vertical is x, or other way around?
I don't remember it. Horizontal is y. So horizontal goes with y, vertical goes with x. Good. Horizontal goes with y. Y equals 7 is a horizontal line at 7.
But wasn't -2 for the x?
Yes, -2 came from right here. It was our x value in our point. So we just kind of went over and found our line right here, which we know it's right here. So we know that this is at -2. So now to write the line, we say horizontal goes with y, vertical goes with x. So we need a vertical line. So we say x equals this point, -2. You see what I'm saying? We just use the x part of it.
I think I did.
Are we all right in general?
I guess this is it.
You look really all right, Amber.
But yeah, I love doing this.
Okay. Okay, so let's find the vertex. So let's do like number 3. So let's plug in again. Y equals 3x squared plus 12x plus 2. Yep, that's right. Okay, so we plug that in, we scroll all the way down, and we have our little interactive graph right here. So we're looking for the vertex. So this is the vertex. It's wherever the global minimum or maximum is. So -2, -10. Which, find the vertex of that, is B again. So this is pretty much just plugging in and finding what you need. So like here, to find the x-intercept, you would just x-intercept right there, x-intercept. For the equation, the value of a, b, and c, you know how to find that just from looking at this. The vertex, you can plug it in, you can find that. The x-intercepts are where it crosses the left and right, the x-axis, and then the y-intercepts are where it crosses the y-axis. Then the axis of symmetry looks like this. And I mean, you can pretty much do all this with Symbolab. It just tells you the information. So we can, that's the same way. So we're going to move on to the next one, since this is really just plug the problem in and put the answers in the answer sheet. Okay. So 3.06. 3.07. Graphing quadratic equations in vertex form. Let me open up the task. Okay, there's the task. That's not what I need. I need this. Okay, so for stretch and most of this is going to be finding it the same way. But we need to go over vertex form before we actually do the problems. Vertex form is a different way that quadratics can look. And it looks like this. Ax minus h squared plus k equals y. This is vertex form. And it's a quadratic, so we know that it's going to be a parabola, which looks like this, just like the rest of our quadratics have looked. So to find the vertex of this, it's actually pretty simple. H, K. So, I mean, if you have 2x minus 6 squared plus 3 equals y, we're going to use this. We're going to use h and k. So we're going to take a positive 6 and a positive 3. This is our vertex for that. So when we go to graph it, all we'll do, plot this point, and then we find out the rest of the information about it using the rest of vertex form. So if we continue on looking at vertex form, if A is a whole number, so 2 here. If A is a whole number that is bigger than 1, so we're -1, 0, 1, we're not looking at those. If it's anything bigger than that, it's going to become skinny. So if this number is anything bigger than 1, you'll see why I'm saying it like that right now, or in just a minute. But for right now, if it's bigger than 1, you know that your graph is becoming skinnier. It's not going to be as wide. If we have a fraction here, so 1/2, your graph is becoming wider. This is called a vertical stretch. So if A is smaller than 0, so if it's negative here, then we are going to have an upside down graph. So A is going to tell you whether your graph is right side up or upside down, just by if there's a negative sign out here. And that doesn't have anything to do with if it's stretched or if it's not. But if you see a fraction, you know it gets skinnier, or you know it gets wider. If you see a whole number, you know it gets bigger. If you just see a negative, you know that it's upside down. If you just see a positive, you know that it's right side up. So this is the reflection, so it's over the x-axis, because your parabolas are usually going to be facing up or down. So if we go to graph these, what we are going to do, I'm just going to work number 1 as our example. So the first thing we need to do is find the vertex. So let me write the problem down and then we will start looking for the vertex. Y equals -x plus 4 squared minus 4. Okay, so we know that our vertex is HK. So -4, because in our form up here, this is a negative sign. So if this is positive, then we know that this is negative, because it's in vertex form. So if it's positive, you're pretty much taking the opposite of whatever it says. So if this is negative, you're going to take a positive. If it's positive, you're going to take a negative. But here, I believe, yep, you keep the same sign. So we have -4, -4. So this is our vertex. So now for domain, we're gonna worry about that in a minute. Same thing with range. So axis of symmetry, which is where the mirror is laid. We are going to. Yep, I'm thinking graph is probably a good place to start with this, but we do need vertical stretch and whether it's up or down. So it is graph D, she says. Graph D looks pretty right to me. And you can pretty much identify that just by the vertex. You don't really need any more information. So by using graph D, let me copy it and see if I can paste it in here. Yes, I can. Okay, so this is our graph. So now that we've identified it, we can tell more useful information about it. So we can tell that our axis of symmetry is right here, which is -4. So it is x equals -4. So this is our axis of symmetry, just AOS for short. Domain and range. Domain is how far left and right the graph goes, and range is how far up and down it goes. So left and right, this is going to go infinitely far left and infinitely far right. It's just going to do it very, very slowly.
Is it a negative?
It is negative for your domain. It is -infinity to infinity. And the reason for that is because over here, all the way over here, we have infinity, or -infinity. And all the way over here, we have infinity. And this is just going to keep going down. And, forgive my terrible drawing, but it keeps going that way forever and ever. Same thing with the other side. They will never end. They just keep expanding that way forever and ever. On the other hand, the range, that does end. That ends right here. It doesn't go all the way up. So we say, okay, if we go from negative, our range is going to be -infinity because it never stops going down, but it does stop going up. So it stops at -4. And I'm going to put a bracket there, but I don't really know if they want you to put a bracket or a parenthesis or what.
I have a question.
Okay, what's up, Jada?
Okay, so when I was looking at range in the listing, it was telling me that you need to use like y and less than or greater than. But I don't really understand how you do that.
Okay.
Because I got put y is less than or greater than -4, but I honestly don't know why I have it.
Okay, so this is one form that you can write intervals, and what an interval is it's just a set of points. So this is the set of points, all points, from -infinity to +infinity. This is the set of all points from -infinity to 4. So we've just kind of written it like that, but we can also write it in inequality notation is what it's called. And inequality notation is for range. You say, okay, if this is our top line, this is our maximum value, right? Well, we need anything less than that. So if we say y, which is usually our range, is less than -4, then these say the same thing. This says y could be anything from -4 all the way down to -infinity. Does that make any more sense?
Yeah.
You sure? Okay.
So do we put the second one or the first one?
Both of them are right. I don't know how your teacher wants it. Okay. So, but if you can put it this way, then you can pretty much convert it to this. They mean the same thing. Just be able to think about it and read it and say, okay, this is less than 4. So, okay. Vertical stretch. We are looking for that number. So for vertical stretch, and I'm just going to put slash compression because you're only going to have one. So for vertical stretch compression, you're not going to have anything because it's just one. It doesn't change at all. If you have a number greater than one, you're going to have compression. If you have a number smaller than one or a fraction, you're going to have stretch. But for this, we don't have any. So I'm just going to put one or none or however they want you to write that.
So for stretch and compression, you put none?
That's what I would put, yes. For the graph, we have that. For reflection over the x-axis, we already talked about that as well, didn't we? Yeah, reflection over the x-axis is down, so that just means is it facing up or down. So just put up, down, whatever. Or yes if it flips, or however you want to write that. So it wants us to work a second point. So let's think about that. Let me look at the lesson and see exactly what they want you to do there.
You plug it into the equation. Once you pick a point, you plug it into the equation.
So it wants you to pick any point and then plug it in?
I think it was, in the lesson, I just put 3.
Okay.
And then I just plugged it into the equation. I think I got -3 for the other answer, if I'm not mistaken.
Okay. It looks like, yeah, it's doing something like that. So let's just pick a number. I like -1, 0, and 1. So I'm going to pick 0. So I'm going to say x equals 0, and we are going to plug it directly into this, which I'm going to copy and bring down here. Okay, so now we plug in, we say -0 plus 4 squared minus 4. So 0 plus 4 is 4. We've still got a parenthesis, squared, and then negative. Minus 4. So I'm going to square first because of PEMDAS. I'm going to get 16. Then I'm going to have a negative left over. I'm going to subtract 4. So I'm going to get -20. So my point will be 0, -20. And this 0 came from this x that we chose. You're welcome to choose anything you want. 10 billion will work. It'll just be hard to work. So I like 0, 1, and -1. They work well. If there's another number you like, choose that. And then that is your second point.
Do we graph it?
It should already be on the graph. So it's saying that at 0 here on the x-axis, it's going to be at -20. So it should cross the x-axis down here at -20. So any questions on these so far?
Can we do one more since it's the last page? Since this is the last one.
Okay, what hard one would you like to do?
There was one with a negative sitting outside.
It's about -3.
Or we can do that fraction. We can do 4.
What time is it?
9:08.
Oh,
Maybe we can do one more one.
Can we do one with a graph thingy? You have to find the equation.
Oh, yeah.
Oh, yeah, that.
Okay.
Cause that's where I'm at. I don't know how to do that.
Tell me a number.
10. Wait, come on, this?
Yeah.
10. What's your 10?
Okay.
Oh, 10. What's 10?
6, 6, 6, 6, 6.
6, no, 10, girl.
Write the equation of the point in vertex form. Okay. So our equation, which we know, is this first blank.
Wait, which number is
I'm on number 6.
Yeah.
Well,
There isn't a number 10.
got a number 10.
There isn't one.
Oh.
The one is this.
That's for the
That's
last
for the
lesson.
last one we did. That's for
We
3
stopped
of
at
6.
8.
Oh, never mind then.
Yeah, that graph is for 3
Yeah,
of
just
6.
D6. Yeah, just D6.
All right. So looking at number 6, the first set of blanks just asks for the equation, which we know. It's this guy up here, if I could get it to scroll. Vertex form. So you're just plugging this in. This. Or y equals, yep.
Y equals something X, something squared.
So that may actually be the answer. It may want the answer up top. I don't know. So it looks like it does want an answer. So never mind, scratch what I said about plugging in just the basic equation, but still have it handy just for you. Okay, so let's find the vertex. So let's go up and say, okay, I'm going, hold on, let me move this down here, and then you guys should be able to see it. Okay, so here is the problem. And what we're trying to do right now is identify the vertex. So I'm going to make it a little bigger just so that's a little easier to do. So I'm thinking our vertex is right here, which is going to be 1, 2, left, and up 2. So I'm thinking vertex is -2, 2. So we have found a vertex. Now we're looking for another point. So maybe we look at this point. Looks pretty easy to me. 0, 0.
0, 0.
So we found 0, 0. So now it wants us to pretty much plug in what we know from what I understand. The equation, I believe, is going to be the answer. So I think it wants you to get to the end and then write it up there.
Oh, I'm trying to see what.
Okay, so if we write this out again, we have y equals a h minus k. Nope. It's x minus h, I believe. Squared plus k. Okay, so we can plug our vertex in for sure. So if we plug that in, y equals a x minus our 2, so it's going to be a positive 2, because what we're going to do is just plug it directly in. We're going to get minus -2, which is going to turn into a positive, squared plus 2. So that is what we have right there.
That's the answer for the equation.
No, it is not.
Oh.
That
Okay, we're not there yet. Okay.
that is going to be the last step.
Oh, it's all the way down here. You have to keep simplifying.
Mm-hmm. Okay, so now that we have our other point as well, we can plug that in because we have an x and a y. So I'm going to now do a 0 plus 2 because I'm using my x plus 2 equals 0. Now I'm using my y. So these guys came from here. And I just chose another point to work because we know it's going to end up correct either way. So now the only thing we don't have in this problem is a. So we can solve to get a by itself. So now if we square, or well, actually we can do our parentheses first. So we're just going to get 2 on the inside, squared a plus 2 equals 0. So 4a, I'm going to move it to the back, plus 2 equals 0. Subtract 2, we're getting a by itself. This gives us negative 2 equals 4a. Divide by 4, divide by 4. We get negative 1/2 equals a. So
The answer for the back call on the simplified one.
now we have solved for a. So what we can do is we can plug it back into our original equation.
Wait,
What's the actual answer?
The actual answer, that's what we're about to write.
No,
Negative 1/2. We got negative 2 over 4 and then divided it down.
okay.
So now we have a, and we can plug that into our original answer, which is that first block up there.
You got it right here. You got him steps that he did right there on the back. You ain't got no back.
No.
You out of luck, man.
You struggling, Jacayla.
No, now you need 7.
Oh,
Yeah, that bad.
Yeah.
Okay, so our actual answer, Jada, the equation.
Wait, give me a minute to get my life together.
I'm still going to write the answer, and then you can get your life together and write it when you get it. Negative 1/2 x minus h, which if we go up, we already have h. We found our vertex, which I'm scrolling back up to find. We plugged it in here. So pretty much we're going to copy this down, except replace a with what a actually is. Plus 2, and then plus 2. And this is the equation.
Hey, he just gave the answer and you took the paper.
I'm gonna quit.
Oh my gosh. Quit tomorrow. Now go.
So all this takes is plugging in, finding the vertex, finding another point.
All right.
I'm sorry, guys. I will go back to the answer and I will leave it there.
Thank you.
There you go.
It's all right with Algebra.
No,
You're so. What are you on this morning? That's his
I didn't know what y'all was doing. Like, I wrote it all down, but I wrote it down underneath because I didn't see it down.
I'm just hungry, bro.
I need stipend.
Yeah.
Is there stipend out there?
We got
No.
tutoring after this.
It is, I'm so
Bro, we
tired.
How about we just do this whole worksheet? Cause this gonna take forever.
Yep, and then we get lunch.
Or we don't and say we did.
No.
I'll do one more.
Thank you.
Okay.
Cause my birthday is today.
It's February 7th.
Actually, to be honest, I was supposed to be doing tomorrow, so technically my birthday is today because I was still being my mom. That makes no sense.
So on things like number 7,
That didn't even make sense.
where it says use GeoGebra to find the solutions to the following system of equations. What you're looking for is you're going to plug both of these in and you're looking for where they cross. So where they cross, that is going to be your solution.
We have to insert a picture of the graph below and we on paper.
Well, take a picture of it. Draw the graphs. I
I'm
mean,
gonna say, I don't see the graph for.
plug it in GeoGebra and
Just make everything simple out of yours.
Dad, these are the whole pictures.
okay, so if we go to GeoGebra,
This other GeoGebra.
that's what I'm doing. So we have GeoGebra right here. I'm going to paste this in, and then I'm going to press the little plus button, and, well, it should paste an expression. Maybe I'll just press enter. And then we do 2x minus 4. How are you?
Morning. I'm fine. How are you?
I'm good. So, feels good to me. So we're looking for the cross. And the cross right there, it tells us what the answer is.
Oh, yeah, 2, 6, 2.
So that's going to be the solution. Wait, no, it is not. I'm sorry.
I'm so confused.
We are missing this. When you paste it in, oh, crap. Okay, so I'm going to type it in, 3x minus 2
But sometimes they don't put the,
up to squared plus 5. Okay, there we go. That's right. So now our cross is at 3, 2. And we also have another solution down here at 1/3 negative 3 1/3. So they're both solutions technically. I don't know exactly why. The solution, we look at it here, it is, we have one solution at 3, 2 and one at 1/3 negative 3 1/3. So if it ever asks you to find solution of two equations, you can graph them and look for where they cross. We will work one more and call it quits for today.
So what's the answer? What if we were insecure about leaving early?
The answer is 3, 2 or 1/3, comma, negative 3 1/3. No, it is not. That is an intersect.
What's the answer number 8?
Just tell us. Don't work out.
Because this says,
Just tell us the answer number 8.
you want to tell paragraph that shown below. Yeah.
Just tell us the answer.
It don't even
I don't
tell
know.
us to just say compare the graph. What am I supposed to say?
You said you win?
I don't know the answer. I don't have the answers to these guys.
Okay, well then read it. And
Go to number 8, because I don't know what he's doing.
I don't even know what it's saying.
It says compare
Okay,
the graph.
so I think what it wants you to do is a parabola with an a value. So what in this is a?
1/2.
Okay, so if we replace that with negative 2, what's going to happen? What about if you change the vertex to 3, 2? Well, I mean, if you change the vertex, just write one with a vertex of 3, 2 and an a value of negative 2, and then draw it on the graph. That's all you got to do, and then just compare them.
Look, we gotta explain something.
I know. And then you explain like what's different about them. Which, I mean, you just say, okay, this one starts here instead of there, and then it
This
faces
one-
up or down, or
This one's lower than the other one.
it stretches, it compresses. You're pretty much looking for the
Let's just do this one.
Let's just put it in GeoGebra and then start writing stuff.
okay.
Don't drop out on that.
We're working on number 8.
I like this mode.
Okay, crap.
Did you just say something?
No. That worked. Okay. There we go.
I like this one.
Okay, so if I put the problem here and I put the graph,
All you use your phone because it's quicker.
I hate man, y'all stop. Y'all go to the sales company, guys, and get an notification.
I'm gonna go next to Albright because he don't cut the text off. This phone.
all right, so let's do this one and then we're done for today.
Okay.
So we compare the graph of this,
Look, we just want
We really do. You don't have to talk. You don't have to
we
talk.
compare this graph to one with an a value of -2 and a vertex of 3, 2. So we have to write the equation for the second one.
I thought we just
So if we have the a value of -2,
That's the new equation? No, that's not it.
x minus 3, I used this, squared plus 2, and we have that equals y. So this is our new equation. So if we go to graph this, our vertex is it's 3, 2. So 1, 2, 3, 1, 2. This is our vertex. And we know that it goes upside down because our a value is negative. So it's going to look sort of like that.
Difference is minus upside down.
So our difference is they start at different places because this has a vertex over here and it faces up and it also compresses a little bit, whereas this expands a little bit. No, vice versa. The fraction, this one expands and this one compresses. So I don't really know what your teacher's looking for there, but that's the differences between them.
Imagine what kind of this.
We're gonna end up having to tell that man that we have a tutor and set him thinking we all get the same answers because. I mean, we often do that, but.
No, we don't. What are you talking about?
Hi, you sent the picture of yourself in a group chat, right, Tracy?
Okay, guys,
Dang.
I am gonna cut it off here.
Bye.
So
Yeah, to them, not to us. We don't know right now.
y'all have a good day.
You were